understood completely?
Yeah.
Okay. I told you this one AIME problem and the ideas. And I told you telescoping rule. Let me see. Aha. Okay, so let me tell you something counting and then we will solve one AMC problem. You should know this idea. So let me check it with you. Suppose, for example, you want to solve a problem, you want to calculate permutations of something. Okay? But for example, an element is before another element. Okay? So let me
Okay.
check from easy problem to hard problem. For example, you should see 1 to 3. How many permutations are there from 1 to 3 such that 1 is before 2?
Uh, just 2.
Yeah. Why 2?
Oh wait, no, 3.
What?
3, 3, 1, 2.
You've calculated all of them. Okay. You say 1, 2, 3, 1, 3, 2, and 3, 1, 2, right? Okay. The answer is 3.
Yeah.
If 1 is before 2, 1 is before 3, it will be easier. It is what?
Just both of them are true.
How many?
Yeah, then it would just be 2 errors.
Hey, exactly. So let me tell you, if for example we have 10 conditions, then and for example from 1 to 3 instead of 1 to 3 we have 1 to 10, do you agree it's hard?
Yeah.
So we cannot write all of them. Let me tell you something. For example, here you say, okay, 1, 2, 3. You can say what? You can say, okay, we have 3 positions. You say, okay, 3 choose 2 for 1 and 2. And in one way you can place that, and for 3 we have one way, it's 3, right?
Yes.
For this one, 1 is before 2 and 3. So you can say 1 is here. For 2 and 3, we have 2 cases. Okay?
Yeah.
Now let's solve another one that is a bit harder. Suppose we have 1 to 5. And 1 is before 2, 3 is before 4. Try this one first on your own.
$30?
Exactly, good job. Can you explain your solution?
Yes, it would be 5 choose 2, choose where 1 and 2 go. And then 3 choose 2 for where 3 and 4 go.
Exactly, because you say, okay, 1 is before 2, 3 is before 4, and 5. So 3 choose 2 times 1, so it will be 30. Okay, all these things have a background idea. I will tell you that background idea. Let's solve some harder problems. Then I will tell you the background idea is what. Next one, we have more conditions. This one, try this one.
Okay. $120.
120. Can you explain your solution?
Yeah, so if 1 is before 2 and 1 is before 5, then you can say 6 choose 3, and then for each of those, there are 2 ways to rearrange those. And then you have 3 choose 2 for the single.
Have you seen problems like this before or not?
No.
Okay, you said 6 choose 3 times 2. Okay, so let me tell you the hardest one to check. Because you said all parts correct. 6 choose 3, 23, 60, 120. Let me tell you the last problem we want to solve. If you couldn't, I tell you the idea. If you know, it means that. So let me tell you part E. Suppose 1 is before 2 and 1 is before 3, 1 is before 4, 2 is before 5, 2 is before 6, 6 is before 7, 8 is before 9. 10 is before 9. 11 is before 9. 9 is before 12. Let me maximize 1 before 2, 3, 4. 2 before 5, 6. 6 before 7. 6 before 13. 3 is before 14. 3 is before 15. Okay. Now try to solve this problem, and one we have our numbers are what, 1 to 15. Okay.
Okay.
It's not hard. You can calculate this, for example, in less than 2 minutes if you know the idea. I just want to check you are, because I've not expected that you can solve this problem. Because you could try this one, see can you solve E, okay?
Okay.
And it's not important to calculate last answer. Only if you say this times this times this, it will be okay. Okay.
I think I need a hint.
Okay, sure. So, let me tell you something. You could solve part A, B, C, D, and you can solve E, but the background idea of all these problems are same. So let's see this what let me when you have you drawn the diagram or not?
Sorry.
Let me tell you diagram is what. When you have something like this, for example, like this one is before 2, 5. Let's draw the diagram first, okay? Like this one. Because checking all these conditions is so much hard. Agree?
Yeah.
You should see the relationship. So you say 1 before 2, before 3, before 4. 2 is before 5, 2 is before 6. 6 is before 7, 8 is before 9. 9 is before 10 is before 9, 11 is before 9, 9 is before 12, 6 is before 13, 3 is before 14, 3 is before 15, right? Now,
Yeah.
yeah, we have two parts that they are not related to each other.
Yes.
Okay, let me tell you, if you want to consider the idea for these problems, the background idea is only these two conditions. First, it says if you have more than one part, we should solve part by part. If there is one part, we should start from the most restricted case. Okay?
Okay.
So let's see it means what. Here, how many parts are there?
2 parts.
Two parts. So we should solve part by part because they are not related to each other. So I have how many positions? 1, 2, 2, 15, right?
Yeah.
So I want to, for example, place these four numbers first. Okay. So I should select how many positions from 1 to 15 for placing these 15. Choose 5. Okay. Now, so we have 5 positions 3, 4, 5. Now, do you agree we have one part because we are focusing on this part? Okay. The most limited element here is what?
Yeah.
Exactly. 12 should be in last position, right? So
Yeah.
12 is okay, and you can erase 12, right? Now we have 4 positions. Again, we have one part, right? The
Yeah.
most limited element is what?
9.
9. 9 should be in last position. You remove 9. Now, how many parts are there?
Uh,
Yes, exactly. So look, when I place 9 in last position, we know all these conditions are satisfied, right?
yes.
So I can remove these conditions. So we have 3 parts. So we should solve part by part. For 8, how many cases are there?
3.
3 or 3. Choose one. For 10
2.
and for 11,
1.
1. So this part is finished, right?
Yeah.
Now let's focus on the rest. Do you agree 10 places are left?
Yes.
Okay, now here how many parts? So let me erase these things. How many parts are there?
1.
1. So we should do what when we have one part?
Look at the most restricted case.
Exactly. Which of them?
13.
13. So for 13, we have how many places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 13, what can we say about 13?
It should go, let's see. It could go at the end.
It can also be here, right? For example, 13 here, 7 here,
Yeah.
right? So we have a better element instead of 13. We have an element that is
6.
more restricted.
Uh,
Which element?
7.
Again, for 7, 7 can be in last position, second last position, third last position, because for
Oh,
example,
1.
1, yes, because 5 can be, for example, here, 13, 7, or 14, all these things. But 1 should be in what position?
The beginning.
Exactly. So 1 in one position, and you can erase because we agree when we place 1, we know all these 3 conditions are satisfied.
Yeah.
So we can
Oh,
remove
and actually,
one and these things. And how many parts are there?
big
So we
parts.
can say what?
Uh, you just look at each one.
Yes, so we can say what, choose what first?
So first we have 14, choose one. Four.
Not 14. Look, we had 10 places because we placed
Okay,
this.
9, choose one.
9 choose 1, 4, 4, for example, right?
Yeah.
And we can remove 4. Okay, then what?
Then we have 8, choose 3 times 2. Or 3 equals 2.
Exactly. 8 choose 3 for these 3 elements. And we can place 3 in the first position. And for 14 and 15 too, right?
Yeah.
Okay. Now then what?
Now we have uh uh we put 2 at the beginning.
Exactly. We have one part again. 2 should be in the beginning. And we can remove 2. Then what?
Now we have 4, choose 1 for 5.
Yes. And
And then 2 times 2 for the last
times 2 finish, right? Okay, we can solve also these cases by this idea, right?
one. Yeah.
And do you agree it's not important that how many conditions are there? We can solve all of them with this.
Yeah.
Okay, sometimes we should use, for example, complement rule, or sometimes we should use casework. But the background idea is this. Let's solve another problem with this idea. I can, let me tell you one problem. You can do this one as homework, okay?
Okay.
Homework 1 because it is similar. Let me tell you. Um, okay. Let's solve this problem first. Suppose if we have 1 is before 2, 3 is before 2, 2 is before 4, this one 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Suppose we have these things and uh, how many permutations are there? Calculate the last answer, okay? You can simplify and find, for example, tell me it is 200, 2000, okay?
Okay.
Try
Is it 400? I mean, no, it's, would it be 6,400?
It's what? 6400?
Yeah.
Completely correct. Good job. Because which two elements are the most restricted one?
4 and 8.
Exactly, 4 and 8. It should be 1 because we have 6 elements less than that. So 4, for example, we should have 1, 2, 3, 4, 5, 6. Then we should have 4. Then we should have 8. Then we should have another 6 elements, right?
Yeah.
Okay, and we have 6 elements here. There are 2 parts when we remove, right? So it will be 6 choose 3 times 2 times 3 choose 3 times 2. 6 choose 3 times 2 times 2. And then a squared because we have same thing here. 20 times 4, 80. 80 squared, which is 6400, right?
Yeah.
Okay, good job. Now, let's try some problems, then we'll solve AMC problem. For this case, the answer is what? It's not hard. 1, 2, 3, 4. 1 is before 2, 3 before 2, 3 before 4. Calculate this one.
Four. Would it be 4? Oh no, it'd be 5.
No, it's not 5. One hint or wanna keep trying?
What would be the most restrictive case?
Here, if you want to apply that idea, mm, 1 and 3 are similar, 2 and 4. We can say
Yeah.
1 and 4 are similar, 2 and 3 are similar. We cannot, so we should, one way is to apply casework, okay? If you apply casework, then you can solve this. Try.
Okay. So my cases are if 1 is the first digit and if 3 is the first digit. But I'm still getting 5.
Again, okay, again 5. Let's calculate together. For example, first element can be what or what?
1 or 3.
1 or 3. So let's consider. First element. If first element is 1, do you agree we can remove 1?
Yeah.
Okay, first element is 1. And we can say what? It is 3, 2, 4. How many cases are there here?
2.
2. Oh, sorry. Yes, it is 5. 1 is before 2, 2 is before 3, choose 1, right?
Okay.
Okay. So let's try um, another one that we have more elements. Try part B first on your own, okay?
Would it be 33?
Mm, your answer is near correct answer. You've used casework, right? Let me tell you easier solution. So you said 33. Let me write your answer. For previous one, we can use complement rule. How it was solution? Let me write with pink. Solution 1, solution 2. Do you agree we can say, okay, when we want to calculate 1 before 2, 2, 3 before 2, 3 before 4, we can say it is equal to 1 before 2, 3 before 4, minus what? 1 before 2, 3 before 4, 2 before 3, or 3 before 2?
2 before 3.
Exactly. This is what?
Oh, and then that would be 4 choose 2 times 2 choose 2.
Yes, minus 2 choose 2 is 1. Minus
That would just be 1.
4 choose 2, 6 minus 1, 5, right? If we apply same thing here, it will be what?
Would be that would be 7 choose 4 minus what?
Which is what?
34.
Okay, understood completely?
Yes.
Okay, now here in this problem it was 7. In AMC problem we should solve for something near 13. So do you agree it will be hard if you want to calculate with casework? Okay, we can also calculate with casework, but we should pay attention to not have careless mistake, but with complement rule it will be so much easier. This problem is for AMC 2022. And I think it was both in AMC 10 and 12. So try this problem first on your own.
Okay.
I think I might need a hint.
One hint, right?
Yeah.
Okay. It says we should have two passes, right? So for example, the first pass can be, what are the cases of first pass?
Uh,
Exactly.
one, two.
1, 1, 2, 1, 2, 3. So if first pass is 1, then second pass is what?
Two, zero, two.
Yes. It means that what elements are before what elements?
So it would be two, team, and then turns back to
1 is before 2 or 2 is before 1 in first case.
two is before one.
Yes, and these things, right?
Oh, yeah.
In next case, we have 3, 4, 2, 13. So 1 is before 2, 3 before this one, right? Then we have 1, 2, 3, 4, this. And you know how to solve each of them, right?
Yeah.
Wanna keep trying or want more hints?
I can keep track.
Okay, sure.
Would it be D? 8178.
I think so. Let's check it together. The first one is let's calculate this one. Again, if we calculate, we can say this one is what, choose what, minus what?
It would be 13 choose 11 minus 1.
13 minus 2, yes. Next one, 13 choose.
10 minus 1.
The first one is what?
13 choose 12 minus
1. Exactly. And last one is when we have 1, 2, 3, 2. 12 and 13 before that, right?
1. Yeah.
Okay, so it will be what?
13 choose 1 minus 1.
Then some of these elements will be what?
2 to the 13 minus 2 minus 12.
Exactly. 2 because we don't have 13 choose 13 and 13 choose 0. Minus 12 will be 2 to the 13 minus 14, right?
Yeah.
2 to the 13 is what?
8096.
8096. This one?
I mean 92. 92. Yeah.
192.
192. Yeah.
Right, minus 4. So 12 minus 4, 8. 8 minus 1, 7. And 1. 8, right?
Yeah.
Okay, good job. So I told you this idea, something before something. Do you know when we have, for example, when we want to divide a polynomial by something, how to calculate remainder?